Good evening, everybody, and welcome to the October edition of the Garden State Java User Group event today. Let's get started. And before we introduce our speaker for tonight, as usual, we always, let's see. Okay, we always have a few announcements at the very beginning. As usual, we'd like to thank our sponsors for their support throughout the year. To talk about what's new, introduce Dan Moore, who will be presenting on JWTs tonight. And we'll have an IntelliJ idea giveaway along with a couple of items, t-shirt and some ebooks from Fusion Auth. So then thanks to Dan on that. You can ignore that link right there. We are using a Google form tonight for that. So first and foremost, our platinum sponsor is JFrog. And for those of you who may have attended in the past, you've heard from Ari Waller, who will usually from time to time, talk about what's new over at JFrog and have some giveaways as well. Azul is our silver sponsor. And we are partnered with DevNexus, and we look forward to helping out with next year's event, which is usually, I believe, is usually February, but I believe it's in April of next year. But don't take that as gospel just yet. And we have our per meeting sponsors, JetBrains, who obviously provides those licenses to IntelliJ IDEA, and Jakarta EE, who provides hosting on Crowdcast that we have used in the past. And what's new? I had this up from last month, but I wanted to keep it up there again. We just created a meetup page last month, and that's the URL you can use to find out what's going on as well, along with our website, of course. And also, too, anybody who is interested in participating in a acceptance testing for Jakarta EE, you can do so by visiting this link. And by testing, it's not formal like TCK testing or any of that, but it's a way, for the Java community to get involved and to try out some examples that are on this, on the Jakarta EE GitHub page and things like that, and provide any feedback. Is there anything broken, for example, things like this. Right now, development is underway for Jakarta EE 10, which is scheduled to be released sometime in the first quarter of next year. So at this point, I'd like to introduce Dan Moore. Oops, okay, hold on one second. There we go. Dan is the head of developer relations at FusionAuth. He's been using Java on and off since 1997, and in the bio that he sent me, he puts in there, "Yay, applets!" And those, of course, those went away after JDK 9, if I'm not mistaken. As a former CTO and engineering manager and longtime developer, he's been writing software for over 20 years. So, Dan, welcome to our quirky little group. We look forward to your presentation, and at this point, I'm going to stop sharing and allow you to check in.
Great, thanks. All right, let me share my screen. All right, so thank you all for having me. I really appreciate this opportunity. So I'm going to talk about Json Web Tokens and kind of why you might use them, how you might use them, things to avoid when using them, and then kind of end up with a little bit of sample code that I'm going to kind of run through. So real quick about my employer, FusionAuth. We're a drop-in user data store and authentication and authorization server. So, something like some of our competitors are things like Cognito, or if you're in the AWS world, or Auth0 or Okta. We have multiple different editions, and that includes a community edition, which is free as in beer. And that free edition supports multiple different OAuth grants, Saml, passwordless. It has a consent model. You can have family accounts and a whole lot more. And how that's relevant to this talk is that we produce a whole lot of JSON Web Tokens. Real quick about me, who cares? You had that great intro from Michael, and my Twitter handle is there on the left if you're interested in learning more about me. Questions in the chat. I think that's the best way to do it. I'm going to rely on the organizers to get those to me. I have the chat open, but I'm not sure exactly who has access and whatnot. We'll also have some Q&A time at the end. And then this slide should have been updated. Don't drop your name in the chat. Fill out that Google form instead. That's the right way to get in to the swag contest for that IntelliJ IDE license, IDEA license, excuse me. And then also we have a t-shirt there that is a FusionAuth t-shirt, And then we have two ebooks. One is about outsourcing your auth and auth systems in general and what you might think about. And then the other is a modern guide to OAuth. So that walks through different modes of OAuth that we've seen, different common patterns, and then also each of the grants, or not all of the grants, because there's a lot of grants, but each of the major grants. And I will say the code in there is in JavaScript, but it's not complicated JavaScript code. It's really just to illustrate the basic kind of flow of the code, of the logic. All right, so let's stop talking about swag and other stuff. Let's talk about JWTs. They are JSON Web Tokens is pronounced JWT. It's a IETF standard, good old 7519. And really what they are is an easy way for one server to produce a token of identity that can be passed around and have its integrity verified without ever talking to the external, to the server that produced it. So that means it's stateless. That's what we mean by stateless. That means that it's great for APIs because you can have one server create a JSON Web Token, pass it to a client, and that client can present it to different APIs, and those APIs can examine that token and know who got that token, right? Who that token represents without ever talking to the API that actually created the token. And for that reason, they're often used as bearer tokens. A lot of identity providers create them. And one of the strengths of JSON Web Tokens compared to other token formats is just the wide amount of support. It's a flexible standard format that has some things you need to avoid, but is widely supported. There's a lot of libraries out there that you can leverage. So I'm going to spend the next 10 or so slides walking through why you might want a JSON Web Token or what problem it's designed to solve. And one thing that's worth outlining here is that we're all engineers. There's trade-offs to be made in every situation. And so there are some times when JSON Web Tokens is the right answer, and there are other times when they just plain aren't. And so I'm going to kind of walk you through a scenario, and we'll talk about some of the strengths and weaknesses of JSON Web Tokens kind of in that context and also throughout the presentation. So we have an over-engineered application here that is a to-do application. So this lets you record to-dos. I have to go get milk. I have to remember to call the dentist, et cetera, et cetera. And you can check those to-dos off. You can add them, update them, delete them. So here we have two services or APIs that are used in this scenario. We have a user API, and then we have a to-do API. Over on the left, we have these clients, which could be browsers, could be native apps, they could be some other kind of application. We don't really care, but the clients need to be able to talk to the APIs, and those APIs in turn are backed by different data stores. And in this case, they're probably both relational data stores, but again, we don't really care. That's hidden from us by the API, or it's concealed from us by the API. So the data store might look a little bit something like this for the user API. We have users that are mapped to roles, and then we have kind of roles. So you can think of, in the context of to-do API, we might have an admin role, we might have a edit role, we might just want to grant certain people view-only roles to our to-dos. The to-dos table or to-dos database only has one table in it, which is just to-dos. So it's a list of all of our users' to-dos. This is what that might look like. And the important thing to note here, other than this is kind of normal DDL, is that the user ID is not a foreign key. So in a normal monolithic application where you don't have multiple different services that are kind of standalone, you might have user ID be a foreign key to the user.id column in the users table. Not the case here. So let's kind of walk through how Dan would go about finding his to-dos. So the first thing I would do is present some credentials. I'd post those to the login endpoint, and the user API would take those credentials, verify that they matched, right? And that typically is a username and password, but it could be other credentials. It could be WebAuthn. You could have MFA involved if it's really super secret to-dos or something like that. But let's just say it's username and password right now. So it's going to verify that I am who I say I am. And then it's going to look at my data in the user's database, and it's going to encapsulate that down as typically JSON, could be XML, could be some other format, gRPC or something, but let's just say it's JSON. And then that gets sent to the client. The client takes that data, which might look a little bit something like this, right? It has, it's a nested object. It has my name, my email, it has roles, it has an ID. So then the client code, which again could be a browser app, it could be a mobile app, could be something else, will actually need to get those to-dos. And to do that, it will have to call into a separate service, the to-do API. Now, this is a very naive implementation. I'm sure a lot of you have already seen the issue here, but the client can post, give me the to-dos of this user ID of 42. And then the to-do API would go ahead and grab the to-dos for that user of ID 42, pass those back to the client, and then the client would present them, right? And so that's where it would give me the checkbox to say, hey, this to-do is done, or the edit screen to change a to-do, or the create screen to add a new to-do. That's beyond the scope of this talk. As I alluded to, there is an issue here, and the issue is that if you pass the user ID as a number, that's going to give malicious clients a lot of surface area to attack and to get data that they that they should not have access to. For instance, they could know that 42 is a numeric ID, which probably tells them something about how many users are in the system. They could also enumerate them and start off with 1, 2, 3, and just get all the to-dos of everybody in your system, which is obviously a horrible idea, or it's a really bad situation. They also could try to find the to-dos of certain users that are privileged, right? And user ID 1 is typically the admin or the root user in a lot of systems. And so they might get that user's to-dos and get access to data they shouldn't have, and so things like the root user's tasks to go get milk after work need to remain secure. I joke, but really we do want the system to have a better layer of protection around people's to-dos. Otherwise, no one's going to use our service. So let's take a second approach. And I call this the opaque token approach. And this is not a bad approach, right? This is one that I would consider to be as useful as Json Web Tokens, just with a different set of trade-offs. The naive approach, please don't use. please don't use that. But this approach works. So in this situation, we have opaque tokens that are created. And an opaque token is just like a string of alphanumeric characters, and we just want it to not be iterable. So when the user logs in, the user API creates a token as part of the user JSON object. That whole object is passed down, that token is extracted, and then every API that needs to be called within the context of that user, right, to get my to-dos or to do other things on my behalf, you basically present that token to. So we present the token to the to API. Now, the to API has no idea what this token is for. It needs to somehow get user data from that. We don't want to trust the user data from the client, right? Because that could be manipulated. So we want to find some other way to get the user data that's trusted. And the way we can do that is present that token to the user API. And the user API will do one of two things. It'll either not recognize that token, in which case it'll probably give back an error message that the to-do API can say, oh, well, this token is invalid for whatever reason. I don't care, but I'm not sending back these to-dos. Or it can say, oh, yes, the user API can say, I recognize that token, and therefore I'm going to give you back the user data, including an ID. And then the to-do API can look in the to-dos database for that user's to-dos and then pass back that JSON to the client, again, where they can present it however they want to present it. So this is an absolutely valid approach. It has some issues or some trade-offs, as I should say. You need to maintain that user token mapping. So that means that if you have 1 million users, you need to have 1 million rows in some database someplace. It could be an in-memory situation, right? Like with Redis or some other in-memory solution, or it could be in a relational database. It also is chatty because every time that token is presented, the API needs to talk to the user database, the user API, excuse me, unless you introduce caching, which has its own complications. And then finally, the user API, again, unless you use caching, is coupled to everything. And so you end up having everything have to talk to the user API, which means that the user API needs to be scaled perhaps more than the other APIs. And certainly it needs to be more available too. Because if your users can't, if your user API is not available, first of all, it's just bad in general because your users can't log in. But if any users are currently logged in, they can't do anything because that token presentation process can't happen. So here are where JWTs come in. And I mentioned at the beginning that they're stateless portable tokens of identity. And so we'll see how they are stateless in that the user API and the to-do API don't actually need to talk for the to-do API to be able to get the user information it needs. So in this situation, the user API generates a JSON Web Token, and this is very important. They sign it. The user API signs the JSON Web Token. Now let's take a quick aside here. There's two main kinds of JSON Web Tokens. There are signed JSON Web Tokens, where you can verify the integrity of the data that's been passed in the token. And then there are encrypted JSON Web Tokens, where you can both verify the integrity and the secrecy of the contents of the JSON Web Token. That latter kind, encrypted JSON Web Tokens, is something I'm not going to cover beyond this brief mention. It's not something I'm very familiar with. It's not something I've seen a lot in the wild. I know it's out there, but I just don't have a lot of experience with it. So back to signing. That signing happens, and we'll talk about the various options that you can use to sign it with, the various key types of keys you can use. But the important thing is that it's signed, and then that signature is transmitted along with the token. And so that's passed to the client, and then the JSON Web Token is extracted and sent to the to-do API. That means the to-do API has a couple of things. It has the contents of the JSON Web Token, but it also has a signature. And it can, independently of talking to the user API, validate that the contents of the token are unchanged. So that means a malicious client can no longer twiddle with that ID or twiddle with the roles, because that signature verification will fail. As I mentioned, you can sign them with a public-private key pair or a symmetric key. And we'll talk a little bit about the differences between those and why you might choose one over the other a little bit later. It's very important, and I'm going to reemphasize that you can validate the contents of JSON Web Token, that they've been passed throughout that chain of flow without, you can validate that they've been passed without the data changing, right? The contents of the token changing without ever talking to the user API. And the other kind of useful thing with JSON Web Tokens is that, as their name implies, they are JSON. So that means you can put in other metadata about the user. So you aren't limited to just a string like you were with opaque tokens. You can put in other information like roles, or if they're on a certain paid edition, right? If they're a to-do API premium user, and so they get a million to-dos, whereas the freemium users only get 100 to-dos, you can incorporate that into your JSON Web Token, into your JWT. So that's kind of the reasoning behind why you might look at a JSON Web Token as a solution for your identity problem. Let's kind of dive into the nuts and bolts of JWTs. So this is a JWT right here. If you were to take this, cut and paste this into a JWT debugger tool, you would see it. But there are three main components to every signed JWT. Again, encrypted JWTs have more components. I'm not talking about those. The three components to a signed JWT are the header, which is in green, the payload, which is in blue, and the signature, which is in gray or white there at the end. The header in green and the payload are both base64 encoded, URL safe base64 encoded, so no equal signs. This means that they can be put in headers, they can be put in cookies, they can be put kind of anywhere that you might use a URL. So they're very friendly. That's why they're base64 encoded. Let's take a look at each of these components. So here we have the header. And this right here, this EYJH, by the way, is a key kind of tip that you're dealing with the JSON Web Token, because that is the base64 encoding of the curly brace. So the header includes the metadata about the JSON Web Token. So is it a JSON Web Token? What's the algorithm that was used to sign it? And then sometimes which key was used to sign it, and other metadata like that. The payload is where things get really interesting. So again, you can see this is a JSON object. We have keys, and then we have values. Some of these key names are standardized. They're incorporated in the actual IETF standard or follow-on standards. Others are just registered with IANA, which is an internet naming body. And then some are kind of the Wild West. You can use them and they just basically mean whatever your application thinks they mean. So the first four claims here, and claims, basically claims are a fancy word for the keys of the JSON object. So the first four claims are ISS, EXP, AUD, and SUB. And those happen to be standardized claims. So ISS is the issuer of the JSON Web Token. So that is the user API in the scenario we walked through earlier. EXP is the expiration time in seconds. AUD is the audience of the audience that should expect this JSON Web Token. So that would be the to-do API in the previous set of slides. SUB or sub is the subject of the JSON Web Token. So that is who this JSON Web Token is about. So that'd be me, Dan Moore, in this particular case. One thing to note about these particular claims are that aside from EXP, the meaning of the claim is standardized, but the actual value format is not. So for example, for ISS, I've seen that be a domain name like it is here. Lots of times it's a URL. I've also seen it for some providers be a random string of digits. It could be a UUID. It could be anything, as long as that represents a unique issuer of the token. The EXP format, the EXP claim is a little different. There, the format's actually defined, and that is the number of seconds since 1970, or January 1, 1970, since the epoch after which this JWT is no longer valid. And that's a required claim because, again, because JWTs are stateless and you never check in with the user API, that we have to have some way for them to not be valid anymore. And the easiest way And the way that is incorporated in the standard is to have them be time-based. You actually have there are other claims like NBF, which is not before. So you can actually issue a JSON Web Token to be valid for 5 minutes a year from now, if you wanted to. You'll notice that the odd and the subclaims look like UUIDs, and that is for a very good reason that I will cover in a little bit. Name is just a name, and then the roles just show you that you can actually put in complex data structures, right? It doesn't have to just be a string or a number. It could be an array of strings, an array of objects, and you can nest those if you want in your payload. So that is, kind of Wild West. You could put in other claims if you wanted to. The signature is a signature. Again, you're not going to decode that very much. You're going to probably use a library to extract that signature out and do the cryptographic validation that the data in the payload and the header have not changed over the wire. So at the end of the day, we pass that JSON Web Token from the user API to the client. The client presents the JSON Web Token to the to-do API, which validates those claims and then extracts out the subject claim, and then it can run this SQL query against the to-dos table and give me back, get the to-dos that should be handed back to the client to present to the user. That's kind of the end state. So let's shift away from JWT kind of nuts and bolts and talk a little bit about some of the use cases of JSON Web Tokens. So I mentioned earlier that they are often used as bearer tokens. And what a bearer token is the analogy I like is a car key. So if I have a car key and I can go, I know where the car is, I can open that car door up and put the key in the lock or put the key in the ignition and turn it, and the car will start for me. And if I give my car key to a friend, or if someone finds my car key lying around and can identify the right car, it will work just as well for both of those parties. The key doesn't care who holds it. The fact is that the key, the car key, is grants access to the car by virtue of holding it. And that is essentially a bearer token. So, that means that you have to be pretty careful with them, because if it's one thing, in the physical world, we're constrained by the amount of people that are around me to see the car key, right? But in the digital world, JSON Web Tokens or other bearer tokens can be stolen and, shifted throughout the world. And you want to take care of the bearer tokens, the tokens that you're being issued by the user API. The upshot of bearer token usage is that if a bad actor gets a hold of a JSON Web Token, and this could happen in a number of ways. There could be a man-in-the-middle attack. There could be the JWT could get logged if it's put in the URL somewhere, right, in a GET request. The JSON Web Token could be stolen by, bad code running on the client, right? If this is a mobile app and the JSON Web Token is stored in like the local mobile database, then that's not protected from other libraries or malware running on the device. It could be taken. If it's a browser and it's stored in local storage or in some other place that's accessible to JavaScript running on the page, then it could be stolen by malicious code that's loaded by the browser. So anyway, in some way, it gets that JSON Web Token, the bad actor does, and it can then present that JSON Web Token to the to-do API, and the to-do API doesn't know any better, and so it will actually get those to-dos for that user and hand it back to the bad actor, because it doesn't have any other way of knowing that, because the JSON Web Token, remember, is signed, but that signature is not tied to the client. The signature is tied to the user API, because that's who signed it, or that's what signed it, I should say. Now, there are some standards out there. Depop is one of them. There's some other stuff kind of working its way through some of the standards bodies that are finding a way to tie a JSON Web Token to a particular client, as well as to the identity provider, to the user API. But that's not standard. And in that case, it wouldn't be a bearer token. That would be, to use the car analogy, that would be like a very cool car key that somehow took my thumbprint and my fingerprint and only turned on the car and only opened the car door when it was me holding that car key. So cool technology, not quite widely deployed. I haven't seen that in a while myself. So given that you're probably using a JWT as a bearer token, you want to think about, how do I safely store this very precious cargo? We recommend at FusionAuth that you store it server side. And so that means running a lightweight server or something like that, so that the client to server communication, clients are matched up by sessions, and then you just basically store the token in the session. And this is known as the Bff pattern. Now, we know that some people, that doesn't work for their architecture. If you're aiming for a super scalable stateless architecture, then you may not be able to do that. In that case, we'd recommend using an HTTP only secure cookie for your browser clients. And what this does is that means that the JavaScript, bad JavaScript running on the browser can't look at that JWT and store it in, send it off to some nefarious bad server someplace. That bad code running, that cross-site scripting exploited code can see the data that's happening. Sorry, let me take a step back. When your code makes a request to the to-do API, that cookie will go along with it, but the JavaScript itself won't be able to examine the contents of that cookie. So that prevents one class of attacks, but the bad XSS code can still look at the results of that data, right? The to-dos, and do something bad with that. But it does lower the attack surface. And then for mobile, you should store it in the iOS keychain or Android secure storage. All right, so let's talk about ways you can shoot yourself in the foot with JSON Web Tokens. And this is something that whenever I talk about JSON Web Tokens, people bring out some of these foot guns. And I think JSON Web Tokens are a widely supported, powerful tool. That means that you need to know what you're doing with them, but they still can be useful. So the first thing I would say is there are a fair number of configuration options, and I would never want you to implement your own JSON Web Token creation or validation code. I would rely on a library. And there, like I said earlier, there are libraries for every application programming language that I know of, and most of them are open source. So I would definitely use those. The second thing you want to do is verify your claims. And the point here is that a library, most of the libraries I've seen will by default check the expiration time of the JSON Web Token, of the JWT, to make sure that it hasn't expired. And then they also will check the signature, which is a great start. But those other claims that I talked about, the issuer claim and the audience claim, those claims you need to check as well. And those are very business domain specific checks, because your identity provider, your user API, determines what those values are, and your it's called resource server in OAuth land, but your to-do API needs to verify that those match what it expects. So The issuer should be the identity provider that is expected to receive this JSON Web Token from, and the audience should be some representation of itself. So you want to make sure you verify those claims. And in the code I'm going to walk through in a little bit, we'll see that as well. So let me switch over to my code real quick. So I have in here this is an Apache 2 licensed sample code project that it uses Maven. It's a couple of simple examples of how you might use a JSON Web Token in a Java project. This is not integrating with Spring or any other framework that you might use. This is kind of a back to basics, nuts and bolt approach. So I wouldn't expect you to actually pull down this code and import it into your project and start using it. This is more of a starting point for you to explore JSON Web Tokens. So we have a couple of different classes here. I'm going to kind of walk through this one, which is using an HMAC algorithm to sign it, which is a symmetric algorithm. And we are going to create a JSON Web Token, and we are going to sign it. And we're going to, wait, I just want to, okay, there we are. We're going to create a JSON Web Token, which is what happens kind of in the first lines 20 to 36. So on line 20, and I'm using an open source Java JSON Web Token library that Fusionoth has created, but this is a similar pattern for most JSON Web Tokens libraries. So we're creating a JSON Web Token. We're setting some of these claims, right? The issuer claim, the audience claim, the subject claim, our expiration time. We're also setting some other non-standard claims like the name and the roles. And then we sign and encode the JSON Web Token, and we get the encoded JSON Web Token. So Michael says, please elaborate on the relationship between the user API and the user database table. So
Dan, that wasn't for me. That was actually from the YouTube chat. I'm just copying and pasting them.
Great. Okay. So, yeah. So from the perspective of JSON Web Tokens, you probably don't care, to be blunt, right? Because a lot of people use kind of a pre-built identity provider that is going to generate those JSON Web Tokens for you. And it's kind of an opaque black box. But in this particular case, I can elaborate a little bit and just say that the user API, we didn't look at the data model of the user API of those tables. I would expect the user table to contain, username or email address, a password field where it's a hash password that's stored, a salt, possibly an encryption method field if it supports multiple different kinds of encryption or multiple different kinds of hashing. No, I shouldn't call it I should call it a hashing method. And then, obviously an ID, and then the roles table will have like all your different roles, and then the user roles table would be a join table between them, so that Dan could have the admin role and the edit role. It's a many-to-many relationship. I hope that explains what you're looking for, YouTube user. But if it doesn't, please go ahead and ask a further refinement of the question. I'd be happy to help. So another question is there an HTTPS only secure cookie? Yes. So you can set a cookie to be HTTP only and set it to be secure. And those are kind of orthogonal. HTTP only says send this down to the browser, but JavaScript cannot access it by the document.cookies JavaScript object. Secure says only send this down if it's a TLS connection, if it's an SSL connection. Hope that answers your question. Okay. Yeah, please keep the questions coming. Love them. All right, so we on line 36, we're printing out this encoded JSON Web Token, and we'll see this when I actually run this code. And again, you can think of lines 18 through 36 as being a very, very abbreviated implementation of the user API. In this particular case, you're always getting one subject and you're not doing any checking of the passwords. Obviously, if this was a real user API, there'd be more endpoints, and the JWTs would differ based on who is actually signing in. It's a demo code, stuff to play around with, not going to be that complicated. Lines 38 through the rest of the class are the to-do API. So remember, the user API generates the JSON Web Token and signs it, passes it to the client, and the client presents it to the to-do API. And the to-do API needs to somehow get the JSON Web Token, the JSON out of the JSON Web Token, and verify the claims and verify the integrity of that token. So that's what we're doing here. So you can see on line 39, actually, line 18, line 21, we have a signer that's that says too many secrets is our secret. And then on line 39, we have that same secret that is used by the verifier. So because this is a symmetric signing algorithm, we need to share that secret between both of our APIs, between the user API and the to-do API. I will talk about other solutions in later slides, just something worth pointing out. Lines 41 and 42, we have our expected issuer and our expected audience, and that is configuration information that is in the to-do API. So the to-do API is going to verify that the issuer and the audience are who they expect it to be. So again, the issuer is who created this JWT, and the audience is who should be consuming this JWT, basically the to-do API in this scenario. So then on lines 44 through 54, that's where we're doing the real business, right? So we are decoding it using this library, and that is going to check the expiration time and the signature matches. And then line 46, we're introducing our business logic, right? We're making sure that our issuer matches who we expect and that our audience matches who we expect. And if any of those differ, we're going to throw a invalid JWT exception. Otherwise, we're going to kind of go ahead and process this, right? Because now we actually have a decoded value, which is just a JSON string that we can pick apart and say, okay, give me the subject claim, give me the roles so that I can, hand back the to-dos that this role has access to. So let's go ahead and run this. Checking. So I see a question there real quick. I'm gonna not address that right now, but I will in a second. So here we can see we have invalid claims, and that's because I have not recompiled this since I made those changes. So let me go ahead and so there we are. So here's our JSON Web Token. And actually, I just want to show you real quick that if we go plug this into a JWT debugger. So this is our JWT debugger, but there are other JWT debuggers out there. But the point is that if you can get access to the JSON Web Token, anyone can go ahead and see what's in here, right? So that is something to be aware of. You don't really want to put secrets into your JSON Web Token. You want to put references that other systems may use, but don't make sense to the client or aren't leaking information to the client. So let's go ahead and let's suppose that somebody finds the JSON Web Token that's issued by FusionAuth, but it was actually issued for a different system, right? It was issued for system 77, but they're still that client is malicious or isn't programmed correctly, and it's gonna present that JWT to the to-do API. Well, we have no idea what that JWT contains. It could contain roles that mean different things. It could contain claims that we don't understand. And so since that JWT wasn't created for us, we should not process it. And we're not going to. You can see that invalid claims was that's the message that was thrown. And what happened is that right here on line 46, this logic clause failed. And so we aren't going to go any further. And so we shouldn't go ahead and get those to-dos or do whatever other work we're going to do. All right. Again, this code is available online. I have a link to it at the end of my presentation. So I'm not going to dig in more here. I'm going to go to the question that somebody posted. So someone said, can you always get from the issuer and apply authorization policy? So I assume, and correct me if I'm wrong, you're talking about going to the issuer and getting information about what that user is allowed to do or not allowed to do. And if I'm wrong in what you're asking, please let me know. But the answer is sometimes, right? It could be that that user API is actually not accessible over the network to the to-do API because the user API could be running in a different organization, or it could be running in a different network that just isn't accessible. There is a standard in OAuth called introspect, where you don't actually validate the claims of your JSON Web Token in the to-do API in the resource server. Instead, you present that token to the user API, and then that gives you back, well, it's called the authorization server in OAuth land, but you present it, and then you get back your information about the token. That can work for sure. That, again, if you're aiming to use JSON Web Tokens so that you don't have to talk to the user API because you want to be able to scale things out and not have all of your system dependent on your user API being available all the time, then having to call the user API to examine the contents of the token doesn't make a lot of sense. That may be a slightly different answer than the question that you asked. Please feel free to rephrase your question if I didn't answer your question. So someone says, is there a GitHub repo for the best practices of JSON Web Token that includes what we are learning right now? So I actually wrote a 3,000 word essay on how to build a secure signed JSON Web Token. And this is basically what this presentation, draws a lot from. And that link is available. I'll put it in the chat, but that link is also available in the end of my presentation. That doesn't have code, just to be, totally upfront. I'm not sure of any GitHub repo I know that has like code that you can drop in, but this definitely covers the concepts. All right, and then someone asked when to use SSO Saml versus OAuth 2. So if you can avoid using Saml, I would be my short answer. It's an XML-based protocol. It was codified in, I think, 2005, and it has some strengths. I'm not as familiar with it as I am with the OAuth code flows, the OAuth grants. But one thing to be aware of is that there'll be times when you're forced to use Saml because that's what your the systems you're integrating with support. And so in that case, I'd use Saml. But if you had like a greenfield development, I can't think of any situation where I would use Saml over using OAuth 2 and OIDC. All right. So I'm going to go ahead and great questions. Thanks for bringing them. Keep bringing them. All right. So let's kind of continue down the JSON Web Tokens. I already mentioned that it can contain arbitrary JSON data. I showed you that if you can get your hands on a JSON Web Token that is signed, you can see the contents. It's just base64 decoding, which there's a ton of tools out there that can do that. So don't put a social security number in a JWT. Don't put a password in a JWT. Don't put an ID that could be enumerated in a JWT. You can put in GUIDs or UUIDs and then have them reference, backend systems. That's okay, but I wouldn't put anything else in a JWT. Just re-emphasizing that again. Don't put anything you want to keep secret in a JWT. Another thing is if you're using HMAC, which is the main symmetric key algorithm, the only one as far as I know that's standardized, you want to make sure your HMAC key, which is a symmetric key, is nice and long and random. There's actually tools out here. This is one of them that will take just a JSON Web Token and it'll basically try to brute force it. If it's an HMAC signed JSON Web Token, you have the signature, you have the header and the body that were used to create that signature. So you can just walk the space, the universe of possible keys, possible keys that were used to create that signature and see if it matches. And it will reveal your key if it's short. Now, the example on this GitHub repo is a 4-character HMAC key. I hope no one ever does that, but it was able to crack that in about 30 seconds. And then, once your key is cracked, then someone can sign JWTs that are indistinguishable from those that are available, that have been signed by the user API or by the authorization server. That's problematic, to say the least. The JWT specification allows the none algorithm, which basically means you don't have a signature. So that turns a JWT that looks like this into a JWT that looks like this, where there's still the 3 clauses, right? There's the header clause, the payload clause, and the signature clause, but the signature clause is empty. The header turns from looking something like this to something like this, where you have alg none. And that means that anybody can, if you're to do API in our scenario, if your resource server accepts JSON Web Tokens that don't have a signature, that means anybody who can find your API can generate a JSON Web Token that will be accepted by your server, and they can put anything they want in there. They can put anything they want in that payload. So they can put in roles, they can put in different IDs, they can put in different names, they can put in different claims, and your API is pretty exposed and pretty vulnerable at that point. So that's like, in some ways, that's worse than unsanitized input, which, people have been railing about SQL injection attacks, and people have been vulnerable to SQL injection attacks for all of my 20 years of software development experience. And that's unsanitized user input, right? But this is worse. This is actually unsanitized credentials, because you're actually presenting yourself as a user, whatever that payload is that represents your credentials, essentially. So pretty bad situation. So don't use alg none, I guess is the lesson, even though the JWT specification allows it. So simple fix is don't allow none. FusionAuth doesn't allow you to actually create a JWT with alg none. As a consumer of a JSON Web Token, you should never accept it. But I used to be a consultant. And so the answer to any question is never yes or no. It's always it depends. And so if you have some other way to verify the JSON Web Token is unchanged, and you know that the signing overhead, right? Because any cryptographic signing overhead is going to take a little bit of time and computational power. If you've benchmarked and know that that overhead is unacceptable for your use case, then use alg-none. I suspect anyone in that situation is probably not coming to an intro to JWT talk at this Java users group, but it's possible. Ways that you can verify the JWT is unchanged. There's you could use client certificates, right? Mutual Tls certificates. If you're on like a private network and you know the identity of every client on that network, that would be another situation where you might feel comfortable using alg-none. But in general, you really should know what the heck you're doing before you enable that feature. So I talked a little while ago about signing with asymmetric key pairs versus regular key pairs. And actually, Michael, how am I doing on time? I want to make sure I'm conscious. I can kind of scoot through some of these slides, or if we're good with time, I think I have about 15 minutes left.
Yeah, that's perfect.
Okay, great. Cool. Okay, cool. So the examples we talked about and the example I showed you was signing with a symmetric key. So that meant that the identity provider, the user API, had the key to sign it, and then that the resource server or the to-do API had a key to verify the signature. That can be problematic because you have to share that secret. So we can also sign with public-private keys, right? So this is RSA, this is elliptic curve keys, any public-private key scenario can work. How that works is the user API, again, after the user is authenticated and logged in and been verified, that when that JSON Web Token is created, is signed with the private key. That JWT is passed down to the client presents it to the to-do API. The to-do API needs the public key somehow to verify that the JWT was signed correctly by the private key. There are a couple ways you can do this. You can, excuse me, you can distribute the public key, or you can actually have the public key be available at a known URL, and that's much more common. So this is a good solution because it scales organizationally. You can actually have this user API be owned by a different part of a company or by an entirely different company, and you don't have to have that company or that organization, you don't have to have the communication, right? Because the to-do API never needs to know the private key. Whereas again, with a shared secret, they need to basically share the same thing. It also is better from a security perspective because the problem with the shared secret and the to-do API having to have the same secret to verify the JWT as the user API has to sign it is that if the to-do API is ever compromised, it's the same as if someone cracked that secret, right? They can steal the secret and then they can go off and sign JSON Web Tokens that are indistinguishable from those that were created by the user API. So if you use the public-private key pair, you keep the private key in one place, right, at the user API. It's not getting spread all over the place. And so you can focus more of your efforts on protecting that one place that actually signs JSON Web Tokens. Key rotation is a little bit easier. You can support multiple keys. However, there isn't any such thing as a free lunch. The public-private key signing is a little more complicated and it is slower. I haven't done benchmarks in Java, but I did benchmarks in another language, and I found it was between 2 and 10 times slower, depending on the public-private algorithm you used, the asymmetric algorithm you used, and the operation you're doing, whether you were signing or verifying. So again, as I mentioned, the To Do API needs that public key, and it could be distributed as a part of the deployment artifact, or as is more common, it could live on the user API. The nice thing about distributing the public key as part of the deployment artifact is that, again, there needs to be no network connection between the user API and the To Do API. And if you want to really lock down your user API, that may be a good thing to do. The nice thing about doing it with a well-known URL is that the public key can change, and the key pair can change periodically, and the To Do API can always just pull down that new public key if it needs it. So this is what that endpoint looks like. This is actually another standard. This is very, very small print. So let's zoom in a little bit. But basically, this is just a list of public keys. So we have the algorithm, we have an identifier, and then we have the key, basically the PEM. And so that gets pulled down by the To Do API and then used to verify that if a JWT comes in and is signed by this KID, right, this UK0P KID, it's going to use this public key to verify that that JWT is valid. If you have more than one key, you can put these keys, this key ID, right? I kind of alluded to this earlier. Your key identifier goes into the metadata of the JWT, and then you basically just grab the key, the public key that corresponds to that key identifier. So this is saying this was signed by the key, by a private key in the key pair identified by KID 42. And I really should update this slide. I should have one of these be key ID 42. All right. Before I step on refresh tokens, someone's asked a question. The question is, so we have a use case. We want your opinion. Well, why, thank you. We have a mule which intercepts and applies authorization and authentication policy and forwards the call to the provider. The provider is dumb and allows access. Is there a smarter way? So basically, I assume by mule, you mean like a gateway of some kind. You know, this is actually an interesting thing. It depends on how much smarts you want to put into your provider, right? You could have the provider reparse that. I mean, so I assume that policy is coming in and it's getting, you know, that token is getting decoded somehow, whether it's a JSON token or something else that identifies the user, and then that policy is being applied that says Dan can access this endpoint and Michael cannot access that endpoint. If that's the case, then, you know, really a gateway is a good place to have that, as long as nothing else can talk to that provider except for through that gateway. Because then all your AAA is in one place. It's easy to manage. You could have the gateway generate a new token, right, with some kind of refined, smaller set of claims saying, hey, this request is actually coming from the gateway, and have your provider do authentication at that level. Obviously, you could do controls around, if you're really trying to isolate that provider, you could do controls around network config so that only the gateway can talk to that provider. I guess I'd probably need to know a little bit more about your use case to give a better answer than that. But I do have my email at the end of this presentation. If you want to give me some more details, I'd be happy to take a whack at doing a better answer for you than what I can do off the top of my head 40 minutes into your presentation. Well, I guess an hour and 10 minutes into your presentation. All right, so refresh tokens. Refresh tokens are part and parcel of using JSON Web Tokens. And the reason is that JSON Web Tokens are meant to be short-lived, right? We see people, we actually have people my CEO was talking about this. We have some people who basically have their JWTs expire after a second, or after a very, very short period of time, and up to minutes, maybe hours, depending on your risk profile. But the fact is that because a JWT, if it's held by anybody else, can be used to represent whoever holds it as the user that JWT was issued for, means that you want them to be very short-lived. Refresh tokens, in contrast, are long-lived, right? They can be days, months, or years. And then refresh tokens are used to create new JWTs. Let's see what I mean by that last statement in a slide or two. So refresh tokens are a compromise between two ends of the spectrum, which might happen if you didn't have refresh tokens in your JWT-based system. If you had no refresh tokens, which basically again are a way for you to get a new JWT, then you could have JWTs very, very short-lived, which meant that every time the JWT expired, the user would have to re-authenticate. And that's obviously a really horrible user experience, right? I wouldn't use Gmail if every time I want to check my mail, I had to re-authenticate. Or you can have them be very, very long-lived, in which case the user is happy because they don't have to re-authenticate, but your security, your CISO will be very unhappy, because if anybody ever steals that JSON Web Token, there will be a very long time period where they can do bad things as that user. Neither of those are good options. Refresh tokens kind of split the difference. So this is how they work, is basically the client in FusionAuth, and I believe in most of the OAuth grants, the client actually requests that a refresh token be generated. The user API generates both the JWT and the refresh token, right? So this is ad authentication, right? The user is logging in. So they're presenting their username and password. To the best of our knowledge, they are who they say they are, right? The question of what happens if someone steals your username and password, that's off the table. We're not talking about that. That's a different risk model. So we're assuming the user can authenticate and they are who they say they are. We generate a refresh token and a JWT. We pass both of them down to the client. The client takes them both, stores them in a safe place. Then it is now going to make requests to the APIs. And it's going to talk to the JWT API. It's going to present the JSON Web Token. So this is the same as the scenario without refresh tokens, exactly the same. So the JWT API, let's say that the refresh tokens are good for 5 minutes. So the JWT API, every time it sees that JSON Web Token, it's going to go through those same validation steps. Does the signature match what I expect? Is this expired? Is the issuer who I expect? Is the audience who I expect? Go through that same checklist. At 5 minutes and 1 second, the JWT API will, when that JWT is presented, that JWT will be expired and the JWT API will fail. It'll send back a 403, right? A forbidden request, a forbidden HTTP response code. And the to-dos will not be sent down, or the operation won't complete. Now the client can catch that, and the client can say, "Oh, I just got a access denied error, but I have this refresh token hanging out here, so I'm going to go try to get a new JSON Web Token." That refresh token can be presented to the user API. Right? This is the key difference. The refresh token is presented to the user API. The JWT is presented to the to-do API, right? To any other APIs other than the user API. So that refresh token is sent to the user API. The user API knows a heck of a lot more about the user than the to-do API does, right? They know, has the user logged out? Has the user paid their bills if it's a premium service? Is the user's account in good standing? All those things. If the user is still like in a valid session, then that refresh token can be exchanged for a JSON Web Token, a new one, expiring 5 minutes from now. That gets sent down to the client again, which can then present it to the to-do API. And the user, that can all happen in, milliseconds. So your end user who's actually trying to add a to-do is none the wiser. So Michael asks, is mutual TLS different from asymmetric keys, or are both of them the same? So no, mutual TLS is different than asymmetric keys in that mutual TLS is both the client and the to-do API have certificates, and they mutually like verify them kind of at the TLS layer, whereas metric keys are the client's not really involved. So the question is with mutual, which is back the Al Nunn question, is can you trust your clients? And the answer for most systems out on the internet, at least, is you cannot trust your clients, and you should not trust your clients. But if you have an infrastructure set up where your clients are issued client-side certificates and present them to the APIs that they're asking for data from, then you have a much better chance of trusting that client, right? You can trust a client that has presented a client certificate that you have been able to validate, that certificate chain. I hope that explains it a little bit. We are in a distributed system here, right? Because the user API and the to-do API don't share a data store. So we cannot use, if we get a deletion request, right? The user sends us a GDPR deletion request or CCPA forget me request or whatever it is, we can no longer use this SQL to delete all of their user data. We don't have on delete cascade anymore. So what we have implemented, and this is not specification, this is, as far as I know, I'm not sure who else has implemented this. This is something that FusionAuth does, and something that you could consider implementing if you were building your own user API. We have a webhook system. And so when basically the client says, hey, delete this user to the user API, we fire off a webhook to anybody else who has said, hey, tell me when there's a user delete event that happens. So that goes off to the to-do API. The to-do API can delete the user's to-dos and then return back from that webhook. And we've actually implemented a transactional system so that the user API won't actually return to the client until all of the people, it's configurable, but all of the interested parties have returned back from that webhook. So if the to-do API for some reason can't delete those users to-dos, it could return back a non-200 status, and the client would not get a success on their deletion request. For logout, basically you're limited to revoking the refresh token. So this is how logout might work. Here we have a client that the user clicks logout right on their client. There's a request fired off to the user API, which basically invalidates the refresh token, and then the client is responsible for removing the JSON Web Token, the JWT, and the refresh token. That's pretty much what you're doing when you talk about logout in a system that depends on JWTs. Now, you may notice that there could have been a JWT floating around out here in this scenario, and it could, the JWT could be good for another 5 minutes, and the to-do API doesn't have any idea, any way of knowing that the user has logged out. That can be problematic, and this is actually a question that we get a lot. We've written, a couple of different perspectives on this, but people say, can I revoke a JWT? Now, remember, the whole benefit of JWTs is that they're stateless and that you don't have to call back to a central server to see if they're valid. They are encapsulated, and they can be verified for validity without ever talking to the user API. So revocation is a difficult problem. And the answer is sort of. You sort of can revoke them. If a user's JWT has been stolen, there's a couple of things you can do. You can rotate keys. And so if you rotate the key that that jot has been signed with, and that key is no longer a valid key, then basically you've basically logged out everybody who has a jot that was signed with that key. Now, in certain circumstances, that's probably a good idea if it's an admin account or something like that. But it's a pretty big impact on your system to invalidate one user's jot. You can wait it out. That's always an option. Again, this depends on your risk profile, right? If your jots are good for 30 seconds and someone has proof that someone else is, that a bad actor has stolen a jot, you may be able to just say, well, for 30 seconds, we're not that worried about that jot being used. You also can do something what I call a deny list. And so what this does is you're actually pushing the state back into the to-do APIs, and you can do it in some elegant ways, but you're basically kind of walking back some of that statelessness of JSON Web Tokens. So let's kind of walk through that. So we have this logout scenario, same as what we had before, but in addition to revoking or invalidating the refresh token in the user API when logout happens, the user API the user API also fires off a webhook, again, to all interested APIs. In this case, it's just one. And that webhook basically says, hey, this jot has been invalidated. Or sorry, this user is logged out. So therefore, any jots associated with that user should be invalidated. Or should no longer be valid, I should say. And that means that to-do API can, in their database or in another data store, keep track of the users that have logged out. And if a request comes in with a jot, in addition to checking everything else, they should check on that jot. The to-do API should check. Remember, check the issuer, check the signature, check the expiration time, check the audience. You add a fifth check, which is, are they on this deny list? Because if they are, that means they've logged out and we should not proceed. All right, last couple of slides here. Thank you for being patient. Jots in Java, what are you trying to accomplish? If you're trying to just generate and parse jots, use a library. There's a number out there. FusionAuth has one. I think it's at version 5. We use it internally. It's pretty battle tested. I think it's nice, but there are definitely others out there. If you're talking about authorization, right? If you're in the seat of someone who's building the to-do API, you could use a filter to do that check. That's probably a good thing to abstract out to a library. Spring has the JWT authentication provider. I have not used that personally, but I know that's out there. JWT tools, there's that debugger that I showed you earlier. That's the second point. The second list item is the example code. And I'll send this all to the organizers of GSUG or GSJUG to post wherever they want. There's that article I mentioned, and then this free code camp actually talks about how to set up JWT-based authentication and authorization in Spring. And that is all. So I want to say thank you all very much for your great questions and for your time tonight. If you want to talk about JOTs or FusionAuth or Bill Murray movies, there's my contact information. You can learn more about FusionAuth at fusionauth.io, and you can follow me on Twitter at moreds. So, Michael, I think I'll hand it back to you, unless there are any other questions.
Yeah, I think I just checked. There aren't any questions anymore. And Dan, thank you very much. This was definitely an awesome presentation. There's so many ways of doing security, and I think this is one of the more popular ways of doing it. The microprofile specifications has a JWT API in it, so people can look into that as well.
Awesome.
But yeah, so first I want to remind everybody we do have giveaways tonight. There was a Google form that was shared on the chat in YouTube. I'm going to give you folks a couple of minutes to enter your name if you're still interested. You do need to be present to win. So let's finish up with the slides. And I'm going to share my screen.
Oh, sorry.
Okay. Okay. And then present. So there we go. All right, just quickly, a couple of upcoming events. The InfoQ Live is happening next Tuesday. It's a series of talks that InfoQ has been providing, during the pandemic, and as a replacement for the QCons that some of you may have attended in the past. QCon is New York, I think San Francisco, Japan, Sao Paulo, and a few places. But until they go back to in-person events, they're having these monthly InfoQ Lives, which is pretty much like maybe 3 or 4 talks for half a day. So I forget what the topic this month is, but you can check that out. EclipseCon is coming up October 25th through 28th. And should have put in here Jakarta 1. And this is the 3rd year of the US version. And what's interesting about Jakarta 1, the first one in 2019 was all virtual, and it was 19 hours. So this was obviously before the pandemic. And so this is the 3rd year. I've been on the programming committee for this, and just stay tuned for details on that. So that's slated for December 7th of this year. And some upcoming meetings. Well, as you may know, the saga of, the Quarkus World Tour, there was, I don't know what happened at Red Hat over there with that, but they did not have a speaker for us last month. And I finally worked out November 9th, so for next month's meeting, and I'm going to try to get information about who the speaker will be and the topic, and you'll get to see that as soon as we get that. And breaking over the last few days for December and for January, we're happy to have Matt Rabel and Josh Long to give a talk on their Spring Native. So they've been doing this together the last couple of weeks at least, and I reached out to Matt and and to Josh, and they're more than happy to present. So stay tuned for the abstract on all that. Just a Spring Native is basically maybe an alternative to Graal VM to take your Java app and convert it to native code. And then also hot off the press, Billy Carando, who's a developer advocate for Oracle, previously with IBM. He's going to present on JDK 18. So by January, the feature set of all the JEPs should be frozen and set in place for the March GA release. So right now there are 4 of them at the moment, and one of them is proposed to target with the review ending on Thursday. So stay tuned for more of that. And also too, we're going to try to reach out to Emily Zhang, who's a developer advocate at IBM, to talk about MicroProfile 5, which is slated to come out next month. And also Mary Glagleski at IBM also.
Get a Harriet Carey.
What's that, Barry?
Sorry, I have to mute myself.
Okay, sorry. All right. And Mary Glagleski, who also is at IBM, has expressed interest in presenting here as well. And Mary is the leader of the Chicago Java user group. So all good stuff. So let me stop sharing at the moment. I don't know, or unless Barry, do you have the winners yet? Have you run the random?
What I'd like you to do, Mike, is read off one prize at a time, and for each prize, I
Okay.
will announce a winner.
Okay, so the first up, we'll start with the IntelliJ. Since
And the winner is Bill Brutzman. Hey, Bill.
oh, Bill, okay. Bill is a friend of the Garden State Group, and also his, as you may know, we were from the old Amateur Computer Group from New Jersey, so we know Bill real well. So he's got the IntelliJ. Okay. Next in order, I believe, is the cool T-shirt from Fusion North that says cat/Etsy/password.
Here we go. And the number that I get is Suala Fatahi. I'm sorry if I mispronounced names.
Okay.
And I should have said the ebooks we can send anywhere. The T-shirt is US and Canada.
Oh, okay.
Sorry.
Is that we can always transfer that to an ebook for who is that? So
I'll give you the name afterwards.
what's that?
I will give you these names afterwards.
Okay. Okay, and so then there was the ebook.
Okay, ready?
Yep.
For the ebook, we've got Andre.
Okay. And then the second ebook.
And for the second ebook, the winner is Bill Rosenfeld.
Okay. Awesome. Can we get confirmation that you're still here with us in the
Yeah, we
YouTube
want to
chat?
get confirmation from each of these people in the chat that you're still with us. We probably shouldn't wait. Let's just move on, okay?
Okay, that sounds good. So you have all the emails. You can share that with me
do
later,
indeed.
right? Okay. Okay, so yeah, those are the ground rules for winning prizes. But so with that, if there aren't any more questions, I'd like to say thank you again to Dan for reaching out to us actually to make this presentation. So that's always desired when when speakers reach out to us. I think that's a cool thing. So thank you again, Dan. Really great presentation tonight. And also thank you for coming out and spending time with us this month. And we hope to get a Quarkus World Tour presentation. If not, we do have a backup in place, and we will share all that information with you once we get it. So with that, have a very good night, and we will talk to you soon.